Welcome students, we'll be discussing here some important types of functions. In the previous video, we have already seen introduction of function and its definition. So let us discuss these important types one by one. First, real function. Suppose a function f is defined from set A to set B. If all elements of set A and B are real numbers, then this function is known as a real function. Or we can understand it that if set A is a subset of set of real numbers as well as set B is a subset of real numbers. Means domain and codomain both are subsets of set of real numbers are, then this function is known as real function. Next, constant function. Constant function. In this case, suppose f is a function such that fx is equal to a constant value, constant number always for all x. Image is always C, constant. As for example, suppose set A is having elements x, y, z and set B is having elements A, B, C and D. If element x is having image C, y is having image C, z is also associated with C. So this is an example of constant image because here each and every element of set A is having only one image which is C here, constant number. So this is known as constant function. Here domain is set A, codomain is set of B, but range of this function f is here set having only one element C here. So this is an example of constant function. Now identity function. A function defined as fx is equal to x. Image of x is itself x. Then this function is known as identity function. Here domain and range both will be same. As for example, suppose you write f1 is equal to 1, f2 is equal to 2, f3 is equal to 3. This is an example of identity function. Next, modulus function. A function f which is defined as fx is equal to mod of x if x is greater than or equal to 0, and this fx is equal to minus x if x is less than 0, then this function is called modulus function. Next function is reciprocal function. Reciprocal function. So here a function f, if it is defined as fx is equal to 1 by x, or sometimes we write fx is equal to y. So if y is equal to 1 by x, where fx is equal to y, then this function is called a reciprocal function, but we should keep it in mind that denominator cannot be equal to 0. So here x is not equal to 0. then this function is known as a reciprocal function. Next function is signum function. This is signum function. So any function f which is defined as fx is equal to mod of x by x if x is not equal to 0 and fx is equal to 0 if x is 0, then this function is known as signum function. So here clearly, if x is greater than 0, fx is equal to 1. If x is equal to 0, fx is equal to 0, and if x is negative less than 0, then fx is equal to minus 1. Because here in this case less than 0, fx is minus 1 as mod of x will be positive. Modulus is always positive, but this x is negative. So finally this will be a negative number. So this will be minus 1. Next, greatest integer function. Greatest integer function. So if a function f is defined as fx is equal to greatest integral value of x, this is known as greatest integral value of x, then this function is called as greatest integer function. Let us make it clear with the help of example. F of suppose 3.2, this will be 3, means the greatest integral value, greatest integer less than this one, less than or equal to. So the greatest integer less than or equal to this much is 3. Similarly, if f is equal to minus 3, then we will write here this is equal to minus 3. If we write f of minus 3.5, so greatest integral value of minus 3.5 less than or equal to minus 3.5, this will be minus 4. F of 3.9, greatest integral value of 3.9, this is equal to 3. The greatest integer less than or equal to this much, which is equal to 3. So this is our definition for greatest integral value. Now let us see polynomial function. Polynomial function. A function f is said to be a polynomial function if fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 up to x to the power n. Here a0, a1, a2, these are real numbers, and n minus 1, sorry, it will be x0, x to the power 0, n minus 1, n minus 2, etc. These are non-negative integers. These are non-negative integers. In fact, here fx is equal to this right hand side is a polynomial. That's why this function is known as a polynomial function. Next, rational function. Rational function. So if any function f which is expressed as fx is equal to px upon qx, where px and qx both are polynomials, then this function f is known as rational function. As for example, here fx is suppose x square plus 1 and here 3x minus 5. Here numerator and denominator both are polynomials, so this function is known as polynomial function. Now let us see one function, onto function, into function and many one function. These are also kind of some types of the functions. So onto function, if fx is a function such that its range, if its range of the function f, this is a subset of this is equal to codomain, this is equal to codomain, then this function is known as onto function. We can understand it very easily. Suppose two non-empty sets are here. Some elements are here a, b, c. Here elements are x, y. A is associated with x, b is also associated with x, c is associated with y. So in this case, range of B is having xy as well as codomain is having xy, both sets are equal. So this is an example of onto function. And if range of f is not equal to codomain, if range of f is a subset of codomain of f, then this function is known as into function. In this case, there must be any sphere element here, suppose z is here, which is not image of any element of set A. At least one element should be sphere here, which is not an image. That's why here range is having element xy and codomain is having element xy, z. So this will not be equal, simply this will be subset. So in this case, this function is an example of into function. Next, one function. If every element of domain is associated with unique element as per the definition, but not more than one elements are associated with unique element, then this is one function. Here in this case, we find that these two elements A and B both are associated with only one element x. So this is not one function. This is known as many one function. So we can define it that if f of x1 is equal to f of x2 implies that x1 is equal to x2, means if images are same, then elements cannot be distinct, cannot be different. Elements should also be same. Then function is one function. Otherwise, this function is many one function. So clearly this is an example of many one function, because here more than one element of set A is associated with one element of set B. I mean many elements are associated with one element, so this is known as many one function. In this case, fx1 is equal to fx2 doesn't imply x1 is equal to x2. Then this function is many-one function. And a function which is having both the criteria of 1-1 as well as on-to is known as 1-to-1 correspondence. This is important to note that a function which is 1-1 as well as on-to is known as 1-to-1 function or correspondence. So, dear students, these are some important types of functions, but we cannot restrict ourselves with these types only. There are some other types of functions, as per example exponential functions, logarithmic functions, trigonometrical functions, etc. But we have discussed here some of the important functions in this video. We have seen it. So you must remember all these functions. This will be utilized in next videos for doing some problems. So students, as usual, I would like to request you to please subscribe my channel IQ Learning and share these videos with your friends also. Wish you all the best. Thank you very much.